Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to make another video for you. This is the third time I've made the video. I've tried to reinstall drivers and I can't figure out how to reinstall drivers because I've got an old laptop. And so I restarted my computer. Hopefully restarting my computer will help the problem. We'll just hope for the best, and I'll do this video a third time. And basically what we're talking about is the t-test. And a t-test is a statistical measurement to measure the means of two samples. So my two samples are class 1 and class 2. The samples have to be small samples, so I've made small samples for this t-test because the t-test uses small samples. So we check the mean of class 1 and class 2, which is sum class 1 over ln class 1 and sum class 2 over ln class 2, and we printed it out. We check the variance of class 1 and class 2, which is np.var class 1 DDOF, that's your degree of freedom, equals 1. We do the same thing for var, and we print it out. We check the standard deviation of class 1 and class 2, which is np.std class 1, and we do the same thing for class 2. And then we print it out, and then we check the length of class 1 and class 2, doing ln class 1 and ln class 2, and we print that all out. And then below that cell block, you can see that we've got the means is 82 and 83, the variance is 120 and 106, the standard deviation is 10 and 9, and the length is 14. And before I continue any further, I would just like it to say that we have to use the libraries, the numpy library and the Seaborn library. That's what we're using to carry out this test. And then to find the t-test with Python and to do it manually, we declare the variable pull var equals ln1 minus 1 times var1 plus ln2 minus 1 times var2 over ln1 plus ln2 minus 2, and that's your pull variance is 113. Then we check our standard error, which is np.square root pull var times 1 over ln1 plus 1 over ln2, and you get a standard error of 4.029. And then we're going to calculate the t-statistics with numpy since we calculated all of the variables. T-stat equals mean 1 minus mean 2 over standard error, and then we print it and we get a t-statistic of negative 0.1418. And then now what we want to do is we want to perform the same t-test, but we want to use the scipy library, which is a scientific calculation library in Python. So tstat pv, which is your p-value, equals stats.ttestend, a equals class 1, b equals class 2, equal var equals false, and then we print it off, and you've got a t-stat of neg 0.1418, which is what we had when we calculated it manually, and we've got a p-value of 0.88832. Now we're going to perform the same t-test on statsmodels, which is a statistical library in Python. Tstat pv dof, that's your degree of freedom, equals sm, that's statsmodels.stats.ttestend, class 1, class 2, alternative equals two-sided, use variable equals pooled, and then we print it off, and you see that we've got a t-stat of negative 0.1418 and a p-value of 0.888, which is the same that we had when we used scipy, so that's what we want to use. And now what I wanted to do is I just wanted to visualize the distribution. So this is the distribution in class 1, and this is your distribution in class 2. So since I'm having problems with my speaker, I don't even know if this is going to work. I'm going to go ahead and conclude this video, but I would like to thank you for watching and thank you for supporting my channel, and I hope I don't have to buy a new computer. Thank you very much.